Hi, my name's Carson Lathem. I'm going to be I did an experiment on how a beam's length is related to displacement, and how the longer the beam is, um, you see an exponential growth in the displacement. So, like I just kind of little briefly mentioned, the purpose of this experiment, like I said, for this creative experiment assignment, I decided to analyze the relationship between a cantilever beam's length and the displacement from a constant load at the end. I wanted to get data to create a plot that would be a visual of this relationship, just to kind of give us as students more better understanding of it. And this experiment was to display the relationship that we see from this displacement equation of PL cubed over 3EI, where P is the force applied at the end of the cantilever beam, L is the length of the beam, and then E and I are constants, and that we know, and then we want to see that as L increases, displacement will increase exponentially. Here's the video of my setup for the experiment. I'll kind of talk over it. So I set up here on a bench actually a tape measure that was used as my cantilever beam, and I placed books on it to hold it still. And then I used, as you can see here, used graph paper on a black surface, and that was where I was able to mark. So with the tape measure, I was actually able to, measure the different lengths of the beam. So I'll get into those. And then, so for my weights, I took coins. I took quarters and nickels, paired them up in threes, and used them as my weights, and put them there on the end of the tape measure, as you'll see here shortly as I'm doing the experiment. So you can see here, this is how I would know the length of the beam, was actually using the tape measure. And then this was the board that I used, and on that board, on that paper, I would mark the end of the beam, the tip of it, where it was located, and so I could measure the displacement. And here is a video of me actually performing the experiment. Here at the beginning, I'm actually showing how I did my initial mark. I used the red marker. That was my baseline. I would do that with no weights on there, mark that point, and then I would, as I'm about to show here, kind of what I did. I kind of move it out of the way so you can see, okay, that's my baseline with that red mark. Kind of moved it back, and then, so this first part was with at 10 inches. So I started with 3/4. I would add 3/4 on there. I took a pencil for a different color marking. Then I would mark where that corner is on the beam, or on the tape measure. And then I would add another set of 3/4. So now I have 6/4 on there, doubling the weight. Mark that point. And then I used 6 nickels taped together, and I placed them on top. As you can see here shortly, it did come, because of the way the tape measure is shaped, it became a little difficult sometimes to get the weight to sit properly. So I gave it a little thumbs up there. But I ended up restacking it here, and this is just kind of a demonstration of what I did. I recorded it just so I can implement and really show what I did. And so here it is. This is when I moved on to my second length of 11.25 inches. And here I am going again, adding each individual weight, or each increment of weight. So 6/4, and then I went from 6/4 to 9/4, and then just 9/4 and plus the 6 nickels. So this kind of process I went through. As I got to the top, it kind of became a little bit difficult to stack. This was just the only change I could find left in my truck. So yep, and then I could show what the graph paper actually looked like here at the end. After I had done it, I would section it off here. This is 10 inches, 11.25, 12.5, 13.75, and 15 inches. And as you can see, the dispersion, the distance between the points grew as the length got longer, which is what we expected. I then took these, I actually measured these distances with a rough estimate using some very small tape measure that was incremented. And I gave kind of rough estimates. They're very not very precise. I don't have a great precise measuring tool. But then I took this data and I was like, okay, I want to make a plot, like I said, of a visual, which is what I did here, as you can see. And so if we go and look at each length, which would be each vertical line, as you can see, as you go from each vertical line, the weight, the separation between the points grows, and that's what we expected, because blue represents actually when I did 6 quarters, orange is the 9 quarters, and then the top is green. That's actually 9 quarters and 6 nickels. So that's the different weights as you move up. But that's kind of what I collected, and then kind of the conclusion I got is, as we can see from the results of the data, we agreed with what we had. As you increase the length of the beam, displacement will increase exponentially. We expected this because we know the equation for displacement has L cubed to the numerator, so as we increase L, it's going to exponentially grow the displacement. Like I said, the experiment was a success since it agreed with how we know what we already knew about how beams deform, and that's longer beams equal larger bending moment, which equals a larger displacement. So that kind of wraps up my experiment that I did. I hope you guys have a great day, and we're almost there at the end of the semester. Thank you.